Hi, my name is Tom Heffel. This channel is all about helping students learn chemistry. In this video, we're going to talk about how we are going to use the ideal gas law, PV equals nRT, and mix it with some of the old concepts that we've already learned about in chemistry, specifically stoichiometry. Okay, so the prompt that we have here is this. Okay, it's like how many grams of water can be produced, okay, through the combustion of a certain amount of propane. Okay, so let's kind of work this problem out. Okay, as far as like the setup is concerned, the question is how many grams of water. So I'm always going to put my underscore grams of water underneath the water, and it's talking about a certain amount of propane. Okay, and the propane is C3H8, and it tells me that my pressure is going to be 2.58 ATMs. The volume is 15 liters, and that the temperature is equal to 40 degrees Celsius. Okay, so I have all this information about propane, the pressure, the volume, and the temperature. And if I use the ideal gas law, PV equals nRT, well, I have three of the four variables. Okay, I have the pressure, check. I have the volume, check. I have the temperature, check. And I know what the ideal gas constant is, which is R, check. So that means I can figure out what moles are by simply dividing both sides by RT. So I'm going to divide both sides by RT. And that means that moles is equal to the pressure times the volume divided by R and T. So I'm just going to rewrite that down. Moles is equal to pressure, volume over RT. I'm going to plug in the pressure of 2.58 ATMs. I'm going to plug in the volume of 15 liters. The R constant is equal to 0.08206, okay? And that's a number that I have memorized. It's on the AP equation sheet. Depending on your instructor, they might give it to you or you might have to memorize it. I will say this, if you do enough of these ideal gas law problems, it's going to be a number that you memorize, just like pi is 3.14, R is going to be equal to 0.08206. And the units on that is ATM liters over mole times Kelvin in the denominator. Okay. Now, the last part is going to be the temperature. Okay. My temperature is in degrees Celsius, and that's an issue. I can't have it in degrees Celsius. I need to have it in Kelvin. So I'm going to add 273 to get into Kelvin. So that's going to be 313 K. So I'm going to bring the 313 K over here. So in my calculator, okay, I'm going to take 2.58 times 15, divide by 0.08206, and then I hit the divide button again because this is in the denominator, and I hit 313. And I will say a common mistake that students make is they take this times this, divide it by this, and then they hit the multiply button, hit 313, and you're basically making it a numerator, okay? If you ever want to multiply these two, you would definitely have to put that into parentheses, okay? So I think it's much easier, this times this, divide this, hit the divide button again, and hit this, okay? And if you get all that, you're going to find out that that works out to be 1.51 moles. Well, 1.51 moles of water, of carbon dioxide, of oxygen, what chemical? Well, if you're using the pressure and volume and temperature of the propane, then when you solve for moles, these are going to be moles of the propane, nothing else, okay? But the prompt is asking you to go to grams of water. So I'm going to take that 1.51 moles, which is propane, and then I'm going to do some stoichiometry to get it over 2 grams of water, okay? And the way I'm going to do that is through a mole-to-mole conversion first. So moles of propane to moles of water. Using the coefficients, it's a 1-to-4 ratio, 1 for the propane, 1 for the propane, and 4 for the water, okay? And then I'm going to convert the moles of water into grams of water using the molar mass. And when I add up 2 hydrogens and an oxygens, it's 18 grams per mole. And when I do all of this math, it works out to be 108 grams of water. Okay. If you don't know how to do the stoichiometry, I do have that in a video, a previous video, so you could look up stoichiometry with Tom Heffel. Okay, so if this information was helpful, please give it a like and subscribe, and even add a comment. Really helps the YouTube algorithm.